Check, check. Thank you very much. Thanks, everybody. You've all remained in the room. You haven't picked any other streams of this conference, so that's a good start. Thanks. That is correct. I am Adam Krieger. This is my talk, The Three Horsemen of the AppSec AI-pocalypse. I chose that title because I wanted this talk to get accepted by multiple conferences, and that's just how you do it in 2025. So what's this talk about? It's about identifying potentially destructive aspects of the inevitable technological revolution. What is that technological revolution? It is, of course, AI. My name is Adam Krieger. I work with online business systems. I'm a principal security consultant. I started out with my career with about 5+ odd years in software development, moved on to become a technical architect, cloud architect. I did a lot of web applications, distributed applications, both server-side and front-end. I worked at various company sizes from startups to enterprise, and then became a consultant and did that for a little while, and then kind of swapped over from producing applications to protecting them. I jumped over into cybersecurity and never really looked back. So now I do exactly the same thing I do before, except way more targeted on protecting confidentiality, integrity, and availability, among other things. Availability is really interesting because I've always been protecting availability as a software developer and technical architect, but now I think that's one of the most interesting things of being in cybersecurity. Both of those professions have equal things to say about availability. A little bit about me. I am a new motorcycle rider. Being 39, I decided to enough risk in cybersecurity wasn't enough for me, so I decided to take the internal combustion engine and move it from about 3 feet in front of me to right between my legs. I am a fitness nerd, I'm a sci-fi nerd, I'm a Golang nerd, I'm several other kinds of nerd. So about ICE, no, not that ICE, but internal combustion engines. I think that there's a really big meaning to them. I like the tangibility of them. I like the understanding that these things are still, that have a physical aspect to them, that they are things that you can roughly talk to, you can feel the vibrations of, they are things that you have a sort of tangible physical relation to. I think that's great about them. Also, we call them internal combustion engines and not metal box containing thousands of explosions per minute because that name just doesn't roll off the tongue very well. So back to our topic, much digression. LLMs, large language models. This is what I've come to speak to you today about. Large language models, let's first of all get the large out of the way because this doesn't really mean anything. Yeah, they're big, but lots of stuff is big these days. We go to Wikipedia, we find out a quote, each token or word, and it's then contextualized or calculated within the scope. Proximity is not great, let's go simpler. Nearness of the context window with other unmasked tokens or words. Dumb that down even further, you get all LLMs are actually word nearness calculators. Let's center on that. What they aren't is things that understand ethics, emotion, legality, correctness, safety, culture, logic, empathy, and so forth. Those are not inherent to large language models. We need to build those in. We can either build them into the data based on the data we train on, or we can enforce it in post. Do we have any audio engineers in the room? Short list. Usually I get at least a few, but fixing it in post is a really common colloquialism in audio engineering, and it's a colloquial for if you can't do anything else, you fix it in post, which means it's not your best option. I wrote an article for online business systems this year called Vibe Coding will create the next vulnerability valley. That's a little bit sensationalist, but I do really believe this. If anybody's familiar with this graph, raise your hand. Fantastic, a few more that time. All right, this is the hype cycle. Any new technology tends to go through something called the hype cycle, or a pattern that people have recognized that looks like the adoption curve. So that initial technological discovery creates this sort of peak of inflated expectations. Everybody's thinking it's a silver bullet, it's going to solve all their problems. They are of course wrong, and once everybody kind of level sets and understands the limitations of that technology, then you fall into the trough of disillusionment. And once everybody gets over the disappointment of it not being a silver bullet, then you actually start having people use the technology roughly in the ways that it can. And so you have this sort of upswing after the fact where the technology is actually employed in the way that it is best suited, and life goes on. I identified, especially starting out my career in roughly 2007, 2008, kind of at the same time that cloud was hitting. I worked for a few years just as a non-cloud software developer, but inevitably just about anything that I ever developed was on cloud. So that's very integral to my career and my story as a professional. If you look at the way cloud was developed, it kind of went into this similar scenario where things came in, everybody expected cloud to solve all their problems, and it reached this sort of hype cycle. It trailed off, and it came back, and everybody started figuring out how to use it in a more accelerated way. In the background, the cybersecurity story there was that as these new cloud resources and techniques came about, so too did vulnerabilities, exploits, attacks, all kinds of things circumventing, exposing data. So initially, when those new implementations are performed without secure patterns, you actually get this big influx of vulnerability as things, or your security posture takes a sharp dip as people start releasing things without secure configurations. It's a brand new tech. Nobody knows how to use it properly. The documentation is inaccurate. People are learning things off of Medium articles and basically just copying and pasting default configuration and implementing things like that. And so you wind up with a whole lot of services, resources, applications that have substandard security. As we move into kind of step 3, mass adoption starts to inherit these insecure choices, and things kind of bottom out. Bad configurations proliferate, and it really isn't until we start hitting that rock bottom where large enterprises, big companies, get hit, or they forget to turn off public access to their S3 buckets and lose a massive amount of files, a massive amount of customer data, and of course have to make up for that by either paying for credit checks for everybody or taking a big old hit in the press. And then on the tail end of this, those secure patterns eventually start to converge. The cloud service platforms themselves actually start implementing these kind of secure configurations by default, and we sort of level back out, and time goes on because we've learned how to use the technology roughly. So that's the vulnerability valley. Inherent to every valley is the fact that it is something that is between two things. So I'm asserting in this metaphor that there is, of course, a downturn in security posture, but of course there is a way through. There is a way to the other side. I'm making that argument. So how do we get to the other side? Well, here's where I put in my shameless consultant plug and also kind of set out some of my biases here. I think that the way to do that is through assessment and advisory. It's through understanding the problem, correctly understanding where we are, the gaps between where we are and where we want to be, and then going through and fixing that. So to have a little fun with this and not have it be so GRC focused and really highbrow, I started looking for a way to figure out how to cut through this and present it all to you and have us understand this. And I've learned of this guy named Mogadat, who, if you look for him on YouTube, you will find a long list of sensationalist YouTube video titles, all really freaking out about AI and how bad it is and what kind of problems it's going to cause us. So I came up with the Mo scale. So as I go through the different things in this talk, I want you to keep in mind that the number of Mogadats is proportional to the significance, severity, risk, or remediation costs associated with the item in question. If that loses you, mo problems. Thank you. So agenda, where are we? This is actually 3 smallish lightning talks all smushed together with a little bit of peanut butter to kind of stick it together. I like homophones, so stacks, attacks, and syntax are how I dub them. Stacks is all about what are we doing when we take GenAI or LLM capabilities and we build them into applications? How does that actually increase the attack surface of the applications that we're building? Attacks is all about how attackers, malicious actors, are empowered with AI capabilities and what they can do differently as a result of that. And then syntax, we're talking about what happens when you empower software developers, software development teams, application teams with AI tools and the key here is built with or by. So either they're using some of these tools to support them building the applications, or they're even turning the applications completely over to these tools and operating in a more agentic fashion. There's another flying buzzword that'll get this talk accepted to at least 3 more conferences. And the kinds of things that they can do and what sort of software vulnerability concerns come out of that. So starting off, let's talk about the stacks. So an AI stack, what you're actually building into these applications is kind of roughly abstracted to this box down below. You've got training data. That training data becomes a model. The model is then used in a prompting and response activity. And of course, then after the prompting and response happens, then you have handling, all the things that happen post-prompt response, where that prompt response actually goes, what's happening, how is it useful, that kind of thing. So this is inherently a little bit of a boil down because we have to get somewhere within a certain amount of time. So focusing on the top 3 sort of concerns that I identified, that's the infrastructure itself, the training data, and the model. So as we can see here, when we're looking for the infrastructure, it's the new tech, but of course it's the same old attack surface. Now, this might be a surprise to the people in this room, but software developers don't necessarily always know what the infrastructure is that their software is running on. Right? So if you introduce a new kind of tech, they still don't know what kind of infrastructure it is that their software is running on. That doesn't matter. However, what does happen is because you're running it on a new tech, sometimes people think that newer equals automatically more secure. That's going to be an issue. We still have to, we're still cleaning up some of the mess that happened when cloud came in and everybody started operating on resources that were built by configurations and automated XAML-driven DevSecOps stacks, or DevOps stacks rather. We're still cleaning up that problem. So now with this compiled on top of it, we're kind of working backwards. We're a little bit behind the game. There's, of course, training data problems as well. Now, these problems are far more nuanced and more dedicated to the actual tool set. Poisoning is a massive topic, both in corrupting the data directly and via supply chain attacks, but also in poisoning specifically for bias and backdoors. So we've got the ability, this is kind of the, you're ruining the integrity of the model, you're making it less useful, or you're actually trying to inject something into the model and use something in a subterfuge-ish kind of way, right? So we can actually, if we're seen another way, we can actually think of that a successful poisoning attack might be hypnotizing the model, waiting for a specific trigger word or phrase to be able to evoke what kind of reaction we want out of it. This can be very subtle. Doesn't mean your model will still continue to pass all of your context checks. It will still produce the kinds of response that makes everybody happy and passes release gates. But of course, when it's released out into the wild, then this secret phrase can actually evoke the kind of reaction that you, as an attacker, are specifically looking for. There is also something called gradient leakage, which applies specifically to distributed training. That's when you've got so much data to train on that you actually distribute your training out to multiple systems. And if you are able to attack a certain number of those systems, or the summary of data that comes out of those systems then is then built back up into the main model, because of course distributed systems exist in training as well. That can create some down chain, really subtle issues, right? The model itself looks okay, and of course, because of the way models are created this day, and the actual checks and figuring out exactly what the biases of these models is not yet fully deterministic, it's really hard to tell when a gradient leakage kind of attack occurs, because of course the differences will be incredibly subtle. You're looking at like small changes in vectors, or like very infinitesimal kinds of differences in the actual model database itself, right? Very hard to detect. There's also something called label flipping, which can happen when you're changing. You can think of hot dog or not hot dog, if anybody's seen this Silicon Valley example here, where you say, well, this is or isn't a certain thing. Well, it really doesn't take too many examples of flipping an is or isn't classification in order for you to get to a situation where the resultant model is actually famously inaccurate. And then, of course, there's attacks on the model itself, or problems with defending the model itself. Now, once the model is actually built into the application, it becomes vulnerable to things like model inversion attacks, where people are actually trying to pull things out of the model via prompt responses in order to start accessing the model's biases, or even, in worst cases, the training data that comes from the model itself. Early versions of ChatGPT you could pull out specific examples of the training data that was actually cited, and that could be anything from full-on reproductions of articles that it was trained on to PII or PHI that was actually built into the model itself, right? There's membership inference, which is just another slightly different way of looking back at the original training data and saying, was this person a member of that original training data? If you get really sophisticated, you can start getting into things like, well, I know that this amount of data was exposed, or I know that this piece of data was out there on the internet, so if I start doing multiple different kinds of attacks on that particular model, how can I figure out if this particular data set was actually used in the training of said model? And then we've got, your more typical kind of things, prompt injection, right? What's actually going into those prompts? We saw another talk yesterday where people are trying to evoke certain reactions out of things by lacing things into something that a software developer is going to use to create a ticket here. But jailbreaking is escaping the actual protections that you put on. So that phrase, fixing it in post, those are guardrails that people are putting on to save face at the end of it, because the model itself isn't actually trained to the specifications that it should be. Consider things like some of the accidental white nationalist exposures that have come out of models in the last, and then how that's been publicized in the press. Well, there are specific guardrails that have been put in place as a result of that after the fact that sort of fix that in post. It's very expensive to retrain the model, hunt through all your training data and say, well, actually, I want to remove that amount of white nationalist content from my model. Well, why don't I just fix it in post? So jailbreaking gives you this sort of ability to sidestep some of those guardrails and get back into what the model was originally stated, or what the original model training data has in its content. And of course, then you're back to square one, where the model's coming up with prompt responses that you really don't want associated with your product. Another one is hallucination exploitation. We all know that models hallucinate a bit because they always want to satisfy the prompt. They always want to make something up, because not answering and not responding is a really bad idea for stock prices mainly, as far as I can tell. And so that kind of exists, and there's really no getting around it until we decide that it's okay for models to not respond or to say, I don't know. So summing up on stacks, infrastructure, it's an issue, but we do have techniques at our disposal. We have baselining, we have secure configuration management. These are known quantities, security teams are aware of them, and really there are ways to suss this out. Training data protections, we can be worried about the data integrity itself. We can monitor that more closely. And of course, we can implement more confidentiality controls to protect that. Now, the big problem, I think, with this kind of issue is the models themselves. How do we know that the models are trained the way we want them to be trained? How do we know that they're going to result in the right prompt responses that are good in all cases? Really, one of our only mechanisms that applies to all of these kinds of things is red teaming. We just have to continuously test and bounce things against these models to try and understand what kind of responses are going to come out of them, and really understand like how well trained is that model. We really have to test it in various different ways. We have to start trying to beat the model up. The same way we are pen testing applications of a more traditional web sense. We have to understand that we're going to have to do that, but not just from to reference back some of my original relabeling, not just from a mechanical point of view, but actually from a linguistic point of view. Okay, and the second part of this is about attacks. So, malicious attackers, what are they empowered with as a result of this new revolution, and what are they going to do differently? They're going to be empowered with a bunch of different new attack types. They're going to attack the app itself differently, or software itself. They're going to attack the SDLC and its supply chain, and they're also going to go against the organization and its members. This is going to be a big boon to discovery. Discovery and finding vulnerabilities in the first place. So one of those techniques is going to be more targeted fuzzing, rather than malicious attackers trying to come up with some of these parameters and spans themselves and having a specific set of endpoints or targets or things. They can now use AI tools to generate those things based on what tends to have been a vulnerability in the past. They can do this for assisted recon, finding more targets. They can do it in their parameterization, finding more potential weaknesses faster, and then they can also do it in actual attack generation and start generation of the fuzzing itself and start creating lists of more targeted, more appropriate parameters to actually pound against websites. It's also a big boon to reverse engineering because, of course, many of these large models are also trained on a significant amount of open source software available in the wild, things that have been exposed, or source code that has been leaked. These models are trained on that kind of stuff too. So attackers empowered with AI are of course going to be able to more quickly decompile applications, more quickly understand and analyze how applications work, and then of course it's going to assist them in classification of the kinds of attacks that they're going to execute as well. Vibe-coded malware. Who's afraid of that statement? So we've heard about vibe-coded software, but vibe-coded malware, of course, doesn't need to stand up to the same standards as the stuff that an enterprise company releases. This means that it can get out the door faster. It can operate. It only has to be, again, the saying, the attacker only has to be right once, whereas the defender has to be right infinitely. That, of course, applies. That's the same thing with vibe-coded malware and any of these things that get created with AI supporting them. Now, AI built into the malware itself can result in end applications that are generatively polymorphic. or they have the ability to mutate and change with the power of AI when they're actually in mid-attack and mid-exploit. So imagine evasion attacks today are predominantly algorithmic or deterministic, assuming that they are headless and they have no like phone home capabilities where the attacker is actually influencing them with new instructions. Well, now you can actually build a bit of model into the actual malware itself and have it try and figure out what it's supposed to do next based on its context. This results in a dynamic behavior that can probably create significant problems for security teams going forward. Signature-based detection becomes somewhat more ineffective, and behavioral detection has to be flexible in order to keep up. There also, and this can result in a sort of scenario where it's generatively exploitative. Attackers are now empowered with this new kind of technique and possibly even create these kinds of fire and forget malwares that are not only difficult in order to find in the first place, but now that they sort of, big giant air quotes, think for themselves at the destination, they can actually be a lot more difficult to fight going forward. Now, when the attackers are going against the SDLC and the supply chain attacks are already and will continue to be a significant source of issue for software manufacturers. But the attacks are actually wide-ranging. It's not just the third-party components finding an exploit in your favorite logging framework or your favorite database engine. We're now able to start injecting new different kinds of social engineering attacks on developers themselves when they're looking for those third-party libraries. We all know the techniques, fake emails, but of course they can also go through Stack Overflow, open source library comments, deepfakes, shallow fakes, and there is an attack that is somewhat prevalent in this sort of supply chain side chaining kind of thing, which is called lib squatting, where I can release a version of an OSS component that looks very similar to a well-known one, and then try and get a developer to use this one instead of that one because it doesn't have a license cost associated with it, for example. And of course, going against the organization is always going to be a prevalent attack as well. So comments in OSS tickets, I was saying, but also software developers and teams might be implementing things based on an intentionally or accidentally problematic medium.com article, default configurations, or as we heard about yesterday, someone bragging about operating, how easy it is to operate things in insecure modes. It's always going to be an issue. Executive spear phishing is on the rise. AI is a massive support and boon to those kinds of attacks. Business email compromise is on the rise as a result. So, attackers with AI in their back pocket. What do I think is the problem here? AI-supported attacks, I think that is probably somewhat counteracted by the existence of AI-supported security testing. Those tools will always be followers, but I do think that there's a lot of money to be made there, so we can probably find that coming out relatively soon. Super malware, we're definitely going to be concerned with that, but of course, we've already got tons of AI-supported SecOps tools out there that may or may not be capable of finding those kinds of patterns. However, I am most concerned, coming from a software development background, of what happens when you social engineer the engineers with the power of AI. When you can make up entire conference presentations that talk about certain things that then development teams latch onto and say, this is the new way to do this, and then end up building vulnerabilities into their applications. Who's saying I'm not one of those conference talks right now? Issues. So, what's our response there? Security awareness and training, which is not great. software developers don't necessarily believe that they need that. So we need to keep talking to them. This is why I say our tools need to evolve significantly on awareness and the counteraction to hubris. Just with things like Dunning-Krieger effect and whatnot, we believe that because we are technical people, we understand these problems more, and we need to take that idea, throw it away, and get back to basics and truly understand if this, then that. How do I really protect myself against these kinds of things? Okay, and to bring it home, I want to talk about syntax, or what happens when you have apps that are built with or by GenAI, and how does that affect your security posture and software vulnerability concerns. So the problems with vibe coding. I think the main issue is you are what you eat, which is to say, what are all of these models made up of when we're training our models that are supporting our cursors and our Anthropic-based IDEs. Where's all that data coming from? It's mostly open source. It's mostly openly published. Potentially it is exposed, but most of the internal actual corporate money-making software that's out there is not being used to train these models. There is none of these companies are signing up to expose their source code repos to the models that are then being used to vibe code other software. That is a thing that no company is really eager to do. Or at the very least, if they're going to sign up on that model, then they want that model for themselves, and that's proprietary. It's not going to help anybody else. There's a concept of complacency in the prevention paradox, which is to say that just because we don't see any security issues doesn't means that there may not be them until, of course, they sneak in through this other way, right? So we actually have to see these things being a problem in order for us to know and to fix them. And the concept of SME-less architecture and the synthetic data collapse, I'm going to get into that. That's the bring it home point. So, fruit from the poison tree. Garbage in, garbage out. Someone else's code, someone else's data, it's someone else's secrets. Model inference own goals. We're understanding that because this code is based off of other things that are also probably insecure, we are then taking some of those concepts and adopting them whole cloth into our applications when we're building this stuff with vibe coding. So rather than having independently humans in the loop thinking, understanding every single line of code that's being built into the applications, we are now taking pieces of code off the shelf and putting them in. There is an inherent bias or an inherent preference to take that thing that has just been given to me and run with it. I have to then change that bias, and I have to be immediately skeptical of the thing that I have just pulled off the shelf in order to counteract that bias. That's an unnatural behavior in software developers. Software developers are used to copying and pasting stuff off of Stack Overflow. They will copy and paste stuff out of prompt responses. There's a big issue with undergovernance, right? New tech will really necessitate a kind of experimentation. I've seen this in many companies that are out there. They want to implement these new AI tools. They want to start engaging in vibe coding. They need to be seen as the new way forward, the company that's on the cutting edge of adopting these new techniques. So they inherently need to lean into AI, adopt it widely. What does that mean? Finding a new product and saying that product is going to be vibe coded. What does that also mean? Because vibe coding is this new shiny thing and they want to get rushed out to production fast, those software products tend to sidestep governance. They tend to sidestep the access control and the change management and all of the other GRC things that we bring in, right? So some of these things we don't actually necessarily know who the owner of these concepts is, right? And we end up getting shadow IT all over again, except now it's not just shadow IT that's being created by members of the organization, but it's shadow IT that's being pulled out of models that are trained on stuff that we've never actually seen before. So we're finding that, or I'm finding personally, that there is a significant amount of overconfidence in the tools that are being presented, in the manners in which folks are being told to use them, and the kinds of capabilities that are coming out of it, and what software teams are thinking that they can build and run with as a result of it. Now, of course, let's lean in all the way and talk about what happens when we get into this concept of not just vibe coding, not just prompt response code generation, but all the way to like an agentic style of development where, and this is, even I've seen in the last month since I even wrote this talk, has been on a sharp rise. More tools are being developed to just completely ignore the actual software developer in the actual construction of the app, and they are there just to navigate the agents that exist in Cursor or whatever IDE you have, and you're just trying to say, you know, go over there, do that, build me a component that does this other thing. This results in a much higher ratio of code line to code reviewer than we've ever seen in the past. At least in more traditional software development, you at least had a higher ratio of code reviewer to code line than before. First of all, you had the software developer themselves, which is writing the line of code. They've written it, so obviously they've seen it. Now, I know that might not count for everything, but you know, that does count at least a little bit. And then, of course, you had the code reviewer, which is another human that they had to explain their code to. If a software developer submits a giant PR, they might be able to convince the code reviewer that that's just fine, depending on their level of seniority. But of course, those two people are then both marking their names on that PR and saying, I'm somewhat responsible for this. In the new agentic manner of software development, we're not really sure who's actually building the software. It becomes a lot more blurry. How much is the human actually in the loop when they're generating a massive amount of code and then kind of reading through it once and saying, oh yeah, it doesn't look like there's anything bad in there. So there are issues with vibe sessions themselves, the sort of agentic pattern, the code review dynamic is an issue, and of course then, you know, we get into this concept of the synthetic data collapse because who in this room thinks that the synthetic data collapse, actually, first of all, who's aware of it? Fantastic. So I'll primer for everybody else. Synthetic data collapse is this theory that if we all stop generating things that are not solely generated out of LLMs, that the quality of the LLMs will just collapse in on itself because it has no human-generated influence anymore. Pardon me. So that is especially relevant in software development because if no new software developers are out there writing new software, then where is all the software coming from? It's all being retrained and reconsumed, and it's a bit of an Ouroboros metaphor where it all just ends up coming out as software that was previously generated. Now, have we written enough software as the human race to say that we have written all software? Not sure. Probably not. There's probably more software to write. But of course, it doesn't take many Ars Technica scrolls to the bottom to find 5 to 6 articles where 5 figures numbers of software developers have been laid off at the next major company. So we're gonna potentially run into this issue. My gut feel is that it will result in some kind of a problem. I don't know exactly what that problem is. I'm sure one of the AI researchers who's being paid more than Lionel Messi will be able to figure that out. But That's a problem for tomorrow. So, MoScale for syntax. I think this is all a big problem. I think fruit from the poison tree is a big issue. I think writing software based off of software that was stolen, essentially, that didn't even look at the licenses that was based on that software, or the license that were attached to that software. I think if we're doing that, then we're already in the wrong place. But what we need to do to fight against that is to bring in more threat modeling, more SAS, DAS, penetration tests, downstream tests, all the kinds of things that I find regularly software development companies don't necessarily spend enough on because it is, of course, just a costing expense. I think under-governance is a big issue, sidestepping existing controls. Now, we can have our arguments about whether SOC 2 really has any amount of teeth whatsoever, but it is still a thing that underpins a lot of the cross-company relationships in this industry. And so it is still something, and something is better than nothing. But I do think the answer is a little bit more policy, a little bit more procedure, some management, and a whole lot of auditing. As someone who regularly writes and modifies and implements AI policies and AI usage policies, they are hard to understand, they are hard to implement, and it is hard to get everybody on board with them. And of course, there's the issue of brain drain, or what happens when we have let go all of our apprentices and we are no longer training people to make shoes. I don't know. So this is probably one of the biggest issues that is a problem for tomorrow. All I can say there is, be kind, treat each other as humans, understand that we're all in this together. And that's my talk. Thank you very much. Are there any questions? Yes.